So today we want to go over graphing piecewise functions just briefly again. We have the first one with only one boundary, and we have the second one with two. So first thing we want to do every single time that we have piecewise is draw out where our boundary is going to be at. So in this first one, our boundary is at -2. So I go to the graph where we draw our boundary at where x is -2. Now I know that there's only going to be one function on the left and one function on the right. So then we look at each equation separately. So the first equation, y equals -2x minus 3, is where x is less than -2. The less than -2 means that it is going to be in this left portion here, because that's where our x values are less than -2. So remember, you have two options of knowing where to start. The big thing is sometimes it makes more sense to take our x value or our boundary and plug it in, and then we know exactly where to start on the graph. So if we take -2 and we plug in -2 into our equation, we would end up getting 4 minus 3, which is 1. That means we would start at 1, and then we move our slope of -2. This would be an open circle at 1 because our inequality here is just less than. So open circle at 1, and then we move our slope of -2. Now be careful on this part. A slope of -2 normally is down 2 over 1, but I want to go on the left side, so I would need to go up 2 over 1. Now as you're doing this, this seems like we are going up, but remember you're reading graphs from left to right, so that is still a decreasing slope, which means that that is still a -2 as a slope. Now, some of you might have thought about just graphing it instead. So you could have taken your original line and said, okay, well, we start down 3, and then we move down 2 over 1, down 2 over 1, or we just go in the reverse way. Notice how you would end up in the same spot. Just remember, you need to then erase those extra points that are not needed. Then we're going to look at our second equation, which is y equals 1/4 x minus 2. Now again, you can plug in the -2 to see where you start on your boundary, but in this case, the y-axis is included in our area that we are drawing this equation, so we can just start at -2. And then we're going to move our slope of 1/4. So that would be up 1 over 4, up 1 over 4, or down 1 over 4. And if you notice, that means that we're not hitting this line at the exact point like we normally would. And that's okay. We can just estimate it here and know that it's going to be a closed circle somewhere in there because this is a greater than or equal to. Okay, now again, if I ever needed to find out what that value was, I would take my -2 and plug it in. So we have 1/4 times -2 minus 2. And this would give me -2 minus 2. Sorry, -1/2 minus 2, which gives me -2.5. Okay, which looks like that's about where we ended up crossing. All right, so let's go ahead and look at number 2. So this one we're going to approach the exact same way, except now we have more than one boundary. So we have a boundary at -4 and at +2. So we're going to draw those lines first. Remember, these are just imaginary lines that help us know that we only can have one line in each portion of the graph. And then we do exactly what we did in the last one. We start with our first equation. Y equals -1/2 x plus 3. So again, we can always start by plugging in our -4. And we would say -1/2 times -4 plus 3, which would give me 2 plus 3, which is 5. So we could know that we start at 5 and then we move our slope. Now, if you don't want to go that out, I'm going to show you what we could have done in the last one. And you can just use this equation. So we can just start at 3 and then move our slope of -1/2. Now, that slope of -1/2 is going in the wrong direction because we need where it's less than or equal to -4, which is in this category over here. So if I want to go in the opposite direction, I would move up 1/2, up 1/2, and now I'm at 5, which is what we got when we plugged in that boundary. This would end up being a closed circle because it's equal to, and we still need to go up 1/2, up 1/2, and so on. Please make sure that you're not drawing a line on these other dots. We need to actually erase them because they should not be on the graph. And then we can move on to our next equation. Our next equation is just y equals 2. Remember, equations like this mean that they are the constant, right? And so that means that this is just a horizontal line at y equaling 2. So if we focus on our inequalities, both of these are not equal to, so both of them would be open at 2. And then we have our last equation, y equals 1/2 x minus 3. So this one is where x is greater than or equal to 2. So I do know, obviously, it's in this last category that we have. Again, we can just start at -3 and then move up 1/2, and then we know where we would start in our boundary. So we keep moving up 1/2, up 1/2, up 1/2, all the way through. Again, if you put any extra dots, make sure that you erase those. You can also take the 2 and plug it in. We'd get 1/2 times 2 minus 3, which is 1 minus 3, which is -2. Again, that's exactly where we started out anyway. So either one works totally fine.